divisible by 14. So from the question scheme, we know that m is an integer, and we want to know whether m over 14 is an integer or not. In other words, we want to know whether m is a multiple of 14 or not. From statement 1 alone, 49 times m is divisible by 14. It means that 49 times m over 14 is an integer. We can cancel this one and this one. 7 is left, 2 is left. Finally, 7 times m over 2 must be an integer. Therefore, m must be divisible by 2. In other words, m must be a multiple of 2. However, not all the multiples of 2 are multiples of 14. For that reason, statement 1 alone is not sufficient. Choices A and D are eliminated. Now, from statement 2 alone, 8 times m is divisible by 14. It means that 8 times m over 14 is an integer. We can cancel this one and this one. Finally, 4 times m over 7 must be an integer. Therefore, m must be divisible by 7. In other words, m must be a multiple of 7. However, not all multiples of 7 are multiples of 14. Therefore, statement 2 alone is not sufficient. Choice B is eliminated. Now, from statement 1 and 2 together, m is a multiple of 2 and m is a multiple of 7 as well. If m is multiple of both 2 and 7, then m must be a multiple of 14. Finally, choice E is eliminated and choice C is correct. We need both statements to answer the question. In the xy coordinate plane, line 1 and line 2 intersect at the point -2, -5. Is the product of the slopes negative? So first of all, according to the question's theme, this is the coordinate plane, and we have two lines that intersect at this point, -2, -5. So we want to know whether the product of their slopes is negative or not. Now, according to statement 1 alone, the product of the x-intercepts of line 1 and line 2 is negative. So, if the product of their x-intercepts is a negative number, which of the following must be true? So, according to statement 1, since the product is negative, then one of the x-intercept must be positive and the other one must be negative. It can be either positive and negative or negative and positive. Now, if we draw the lines, for instance, it can be line 1 positive and line 2 negative. Now, line 1 has a positive slope and line 2 has a negative slope. Therefore, the product of their slopes is negative. But what about this case? Line 1 and line 2. Now, here line 1 has a positive slope and line 2 has a positive slope as well. Therefore, the product of the slopes is positive. Now, since we have two different cases, statement 1 alone is not sufficient to answer the question. Choice A and D are discarded. Now, from statement 2 alone, the product of the y-intercepts of lines 1 and 2 is positive. So, according to statement 2, which of the following must be true? So, since the product must be a positive number, then both of the intercepts must be positive or negative. Now, for instance, if both are positive, we have the following. This is line 1 and line 2 should be something like this, for instance. It can be a case that there are two lines with the same with positive slopes that intersect at point -2 and -5, and in that case the product of their slopes should be positive. Now, what about negative y-intercepts? It can be something like this, line 1 and line 2. In this case, the slopes has different signs. The slope of line 2 is positive and the slope of line 1 is negative, and therefore the product of the slopes is negative. So, since we have two different cases, one when the product of the slopes is positive and one when the product of the slopes is negative, statement 2 is not sufficient to answer the question. Choice B is discarded. Now, we need to use both statements together in order to know what is the answer of the question. Now, from statement 1 and 2 together, the lines must fit to this requirement and this requirement. So, same sign for the y-intercepts and different signs for the x-intercepts. So we can do the following. It can be positive x-intercept for line 1 and negative y-intercept for line 1 and negative x-intercept for line 2 and negative y-intercept for line 2. This is the only case that fit to both statements, and in this case the product of their slopes is negative, since line 1 has a positive slope and line 2 has a negative slope. Therefore, we need both statements to answer the question. Choice E is discarded. Choice C is correct. A combined total of 144 glass balls are stored in 2 crates. Of these, a total of 9 are broken. If there are exactly 5 broken glass balls in the first crate, what is the number of the glass balls in the second crate that are not broken? The question still states the following. There are 2 crates. The total number of glass balls in both crates is 144. There are broken glass balls and non-broken glass balls in each crate. There is a total of 9 broken glass balls in both crates. So, how many non-broken glass balls are there. $144 minus 9. 135 balls are not broken. Then 5 broken glass balls are in the first grade. How many broken glass balls are in the second grade? 9 minus 5. 4 broken glass balls. They want to know the number of glass balls in second grade that are not broken. Let's say X is the number of non-broken balls in second grade and Y is the number of non-broken glass balls in the first grade. We want to know the value of X. Now, let's go ahead with statement 1. The ratio of broken glass balls to glass balls that are not broken is the same in both grades. The ratio of broken glass balls in the first grade is 5 over y equals 4 over x. And we know from the questions theme that y plus x equals 135. Now, we can do the following. Cross multiply. 5 times x equals 4 times y, and y equals 5 times x over 4. We can replace y here and solve for x. So statement 1 alone is sufficient. Alternatives B, C, and E are eliminated. Now, let's go ahead with statement 2. The ratio of broken glass balls to glass balls that are not broken in the first grade is 1 to 15. Broken glass balls to non-broken, 1 and 15. We solve for y equals 5 times 15. And we know that x plus y from the questions theme is 135. We can solve for x and we will get the value of x. Therefore, statement 2 alone is sufficient. Alternative A is eliminated. Choice D is correct.